Good morning, afternoon, evening, or night. People, welcome to the area of triangles from side angle side. Okay, so what does that mean? You're given SAS, as in a side followed by an angle followed by another side. Well, that's we're going to use this to calculate the area of any triangle, okay? So a couple of things. We need to differentiate between our sides in order to derive this. We're going to call one side side 1, one side side 2. We're going to call the angle in between a theta. Some people would call that the included angle between these sides. Not a big deal. And I like to call side 1 with a tick mark and side 2 with a tick mark. So I hope you don't mind. But let's review some basics and let's change this triangle into a nicer triangle to work with initially. So here we have an equilateral, equiangular triangle. And a reminder, the area of a triangle is the base times the height divided by 2. And that's because if you have the height and you multiply, you get a rectangle. Half of that rectangle will be the area of this triangle. I like to think of it as half of the base times the height, but that's the same thing. So this brown line here, or orange or tan, or what is that? Rust. That rust colored line is the base, okay? So this, I don't know, olive green colored line is the height, okay? So let's label some things a little better than that. Also notice that side 1 or side 2 is our base. So I've put that into the equation already. If we can get h in terms of side 1, then we have the area of a triangle from SAS. So what if we used SOHCAHTOA here on this blue triangle? Given this reference angle, we have an opposite and we have a hypotenuse. I know that this is an h and that is highly confusing, but this is opposite and the hypotenuse is always across from the 90-degree angle. So that means that this is not an adjacent problem, and we definitely need to use that hypotenuse. This is a SO problem. Sine equals opposite over hypotenuse. The sine of the angle is equal to the opposite over the hypotenuse. Let's solve for that opposite piece, that h, by multiplying both sides by that denominator, that side 1, and we get that the height is equal to side 1 times the sine of the angle. Let's get rid of some other nonsense and let's plug that into our equation. All of a sudden, we have the area of a triangle if we have a side followed by an angle followed by a side. There's our formula. Why does that work? It works this way too, guys. What did I do up here? Let's go back. Notice that this one was red and this one was the olive green. I'm just switching the colors here, okay? The order of multiplication doesn't matter. We still have that this height measured from a different side is still going to be side 2 times the sine of the angle, okay? And to really blow your mind, this works on any triangle, okay? So here we can very clearly see we have the base. This height is equal to side 1 times the sine of this angle, so it's still base times height divided by 2. And then if you look at it the other way, this is probably the weirdest way, but sometimes the height of a triangle is on the outside of a triangle when an angle is obtuse, for instance. In this case, this height here is still equal to this side 2 times the sine of the angle, okay? I have moved this over. Instead of just switching the colors, okay, up here, I actually moved it over so that you could see that the height was all together. But the order of multiplication doesn't matter. So that's our formula. Let's see it in action. Oh, I moved it over. Finding the area. Well, here's our formula. Half of side 1 times side 2 times the sine of the angle in between. Head over to any old calculator and type it in there. A half times side 1 times side 2 times the sine of the angle in between is equal to 81.7 blah, blah, blah. Feet squared. Don't forget to box it. I hope that you have a really nice day.